As concerned the effect of sterilization time and the temperature on the medium component, and we just in our previous module that if we want to have a short holding time, having a high temperature, then it will be preferable of a continuous steam. So as concerned the sterilization process, we can classify the sterilization into various types. One is in situ sterilization and other is ex situ sterilization. What is in situ sterilization? In situ sterilization of the fermenter on the same place where the fermenter is. So we just supply the steam to the fermenter and then to sterilize. And that is known as in situ sterilization. As concerned the ex situ sterilization, that only help only a small scale or a shake flask level, because we keep our material or a fermenter vessel into the autoclave and then we sterilize. So this is known as ex situ sterilization. You know that we discuss in detail the in situ and ex situ sterilization while discussing the scale of fermentation, because when we say the lab scale fermentation, that only have ex situ sterilization, but on pilot scale and industrial fermentation we have only the in situ sterilization. But here on the other hand, the sterilization can be divided into two types on the base of the mode of sterilization. One is batch mode and other one is the continuous mode. So each mode has its own limitations. Some are the benefits, some are the, we can say that, the disadvantages. So the relative merit of the batch and continuous sterilization. So what is batch? So if we sterilize in a batches, having all the medium on the same time, either we sterilize the medium in a stream and then we gradually feed into the fermentation medium, that is known as continuous sterilization process. So as concerned that advantages of the continuous sterilization over the batch sterilization, so we can say that the continuous sterilization is superior maintenance for medium quality. So in this case we can give a high temperature for a short time, so it is better to maintain the medium quality. So in this case it is easy of scale up, easier automatic control, reduction of surge capacity for steam, reduction of sterilization cycle time. As concerned 6, under certain circumstances the reduction, it reduces the fermenter corrosion, because fermenter is just only have no medium and then we can sterilize by the steam, and then if we have not the sterilization cycle time by time, that increase the life of the fermenter. So as concerned the advantages of the batch sterilization over the continuous sterilization, it require low capital investment, low risk of contamination, because the process requires the aseptic transfer of sterile broth to the sterile vessel, because in continuous culture we need a sump and dump lines. So if our sterilization process, that is very good, but there is any leakage in those lines, then there is more risk. So in batch culture the risk is less than the continuous, but in batch culture it is easier to handle. So manually it is easy to control in batch culture, in batch sterilization. As concerned the batch sterilization, it is easier to use medium containing with a high proportion of solid matter, because continuous sterilization can only be applied when there is a less thick and there is more flow. But those media which have a viscous and have a less flow, then will be the batch sterilization option. So as concerned the early continuous sterilizers were constructed as a plate heat exchangers, and these were unsuitable for two accounts. Number one, the failure of the gasket between the plates resulted in the mixing of sterile and unsterile steam, because when there is a heat exchangers and then there is a plate between the two, and if there is any leakage, then the mixture can happen of the sterilized and unsterilized medium. So the particulate component in the medium would block the heat exchangers. So because there are the very small passages, so sometimes when there is a viscous medium and then that can block the heat exchanger, then there will be a more loss. So as concerned, the modern continuous sterilizers are double spiral heat exchangers in which the two streams are separated. When there is a chance of mixing of the sterilized and unsterilized streams, then in the modern case the sterilizers have a separate, we can say that double spiral heat exchangers in which the two streams are separated by the continuous steel divisions. So then the spiral exchangers are far less susceptible to the blockage. But the major limitation to the adoption of the continuous sterilization was the precision of control necessary for its success. So this precision has been achieved with the development of sophisticated computerized monitoring and the control system, resulting in the continuous sterilization being very widely used, and it is now the method of choice in fermentation, in industrial type fermentations. So the nevertheless of the batch sterilization, that is the still use. So we can say that the continuous sterilization has its own advantages, but due to the more cost, capital cost, and then most of the fermentation and most of the industrial fermentation use batch sterilization. So we will discuss in detail in our later module about this.